Good morning, friends. Today I just really wanted to sit down and break down our lab report, which I feel like might be a little confusing to some of you, especially those of you who aren't here in person. So I wanted to make this video sort of explaining what we're doing and breaking down what I need from you guys to do. So in this project, even if you weren't here, I want you to practice looking at data and analyzing that data. And so what our in-class, in-person peers have done for the past couple weeks is go down to Hawcreek and study two parts of Hawcreek. One, the part by the People's Trail and the bridge, where we've done our biology projects with the invasive species, and also the other side over by the bridge, the other bridge, the hospital. So the bridge by the hospital. And pretty much what your peers did is they chose 200 feet of the creek to study. And so we haven't yet looked at the chemical breakdown of everything that's happening in the creek, but we have begun looking at the habitat quality of the creek. And so we're using Hoosier River Watch to really help us understand what a healthy creek looks like and why. So we're thinking about what is it that contributes to creating a healthy creek. So in our project, our goal, our actual science experiment and question is, which of the two ecosystems that we are studying is a healthier ecosystem? That's our question. So you know what? I'm just going to go ahead and write that down here. So which of our two ecosystems that we are studying is our healthier ecosystem? And I want you guys to just go based off the knowledge that you have right off the bat. Which one do you think maybe has more human influence? Which one do you think is a healthier ecosystem? Just based on what your knowledge is of what a healthy ecosystem looks like. And so if you take a look at the Hoosier River Watch manual, all of which is linked to your It's Learning by environmental science agendas, or it doesn't even have to be in your agendas, in your resources folder, where it says breaking down the system readings, chapter 1, 2, and 3 of the Hoosier River Watch study breaks down what we're doing, how we're doing it, and why we're doing it. So the habitat assessment is really, it will help you understand a document like this better. So in the habitat assessment, you and your peers looked, or not you, but your peers looked at how much substrate was there, how many rocks were there, what areas were there for fish to hide under cover, how curvy was the stream, how did the plants on the creek beds and the stream look like, how deep was it, how fast was the water moving, and were there any riffles and runs of areas of fast moving water? And so all of these pages leading up to it will give you more information as to how we collected this data and why we collected this data. So it will help break down this table. Without that information, you cannot understand what's happening here. So what your peers did is they created all of their data. We took all of their data points, and we're almost treating these like different trials in an experiment. And so we have an average of all of these that we would like to collect. So we have substrate average, we have the fish cover average, we have stream shape average, we have stream forests and wetlands average, etc., and etc. So this is the information that I want you guys to see putting into your tables. And I created a lab resources folder for you with some examples of formal lab reports of mine from back in the day. And so I want you guys to specifically use this to get an idea of what your formatting should look like, right? So if you are referencing any of your charts, you should have an in-text citation referencing figure 2. If you guys are working on creating a table, your table should look like this, with a heading, a very clear understanding of what was happening in that table, with units at each column, and a table caption that is italicized. I need you guys to have your titles and your abstracts listed like that. Your introductions should exist like so. So really, I'm asking you guys to push yourselves and try your best. Here's some additional information about how you might want to include your information. And this is an easy broken down high school level. But if you have questions, you can really back it up using information here. So to start, I want all of you guys to create a Google Doc called Water Quality Hawcreek Report _ last name. If you guys made a previous document, I'm actually going to backtrack and ask that you just make this one, because I think it'll be easier for me to tell you guys what to do. And as we go, I'm just going to add more and more information and give you more information as to what I hope to see. So let me make sure that this is in the correct folder in my drive. CSA New Tech 2021, Environmental Science, breaking out the system. All right, so this is an example for what your table should look like. I am actually going to put one should be called bridge, and one row should be called bridge, and I think one row should be called hospital. And assessments of Hawcreek, and we're going to take a look at this information, right? So first, we should probably note that this is stream, forest / wetlands. We're going to say that this is average depth and velocity. We're going to say that this is riffles and runs. And this is the average total, or a total of the averages, right? That's exactly what it is. So we're going to copy and paste this. The reason I want you guys to make a completely new table is because of formatting. I want us to practice while we're in here how to properly format and make something look as professional as possible. So we're going to say like substrate, right? Fish cover, stream shape, stream forest, wetlands, depth and velocity. Ooh. Insert column right, insert column right. Ooh, what did I just do? Oh, I think I deleted it. All right, insert column right. So runs and riffles and runs, I mean. And total of the averages. So maybe one thing that we could do is actually make this a little bit smaller if we'd like, to just try to make it fit slightly better. And then we're going to copy this information in, right? 16.6, 11.0, 16.7, 20.2, 9.4, 13.8, 87.7. And then looking at how our lab report resources guide tells us that this should be formatted, I want you guys to unbold everything that I have bolded. So we can go ahead and unbold that, and we can unbold this, and really keep the important information. So I want you guys to try to make another table of the average habitat quality assessment of the Hawcreek Hospital area. So you'll get that information right here. And I also want you guys to really focus on a couple other things this week. So we will have our hypotheses, again, answering this question. And I also want you guys to start working on your introduction. So your introduction is where I need you guys to start telling me what is Hoosier River Watch, because we're partnering with them to do this. What is the purpose of keeping track of water quality in streams? Why is it important to do that? What do we know makes a healthy stream, right? So a little bit of it is a Hoosier River Watch, and then a part of it is water quality and why we bother. So all of this stuff sort of goes in that section. And then the last section is, I think, what are the areas of Hawcreek that we are studying? And all of the answers to this, I think, and like um, how, like, so what do we have to study? Like, what measurements must we take? Alrighty, so with that in mind, I think all of these answers are in the Hoosier River Watch, like breakdown their manual. So answers are in Hoosier River Watch manual. Make sure that you're using APA citation as you go and as you reference each of these things. And really, for now, this is where we should be. I think that I should see at least 2 tables for habitat qual, or not 2 tables. I want you guys to just insert the hospital information right here. And then I think we should have another table that, for now, that looks at stream flow. So stream flow is how fast water is traveling throughout like a space of time, and it sort of calculates how much friction is at the bottom of the water. And so it puts all of that information together and then tries to create a general idea. So what your peers have here is, dear Lord, crap. Okay, I can't get to it right now, actually. What a mess. All right, I can't get to it, so don't worry about that yet. But for now, this is what I want to see you guys have, and I want you guys to work on this today. And that is all. I'll talk to you guys later. Have a good rest of your day. Goodbye.